Hello, welcome to lesson 11 of my Erlang tutorial, and in this lesson we'll be discussing custom control abstractions. So you might notice that so far I haven't introduced any statements like in other languages if or for each or while, do while or any other of such things. Everything in Erlang is written using pattern matching and higher order functions. And in this video, I would like to demonstrate one example of module which will define multiple functions, which will help with implementing this kind of, uh, let's call them statements in other languages. And I will also talk about the advantages of this like custom control abstractions. Let's start. I will create a new Erlang module and I will call it loops. So first, if you remember, I need to type something like this, and then I want to say to tell Erlang that this will be module loops, and then I will define three functions. First will be for, which will be the implementation of a for loop. Second one will be for down, and this implementation implements the range and the step, increasing step, the incrementation. So from 1 to 10 or 20 to 100, while this for down will implement decreasing value or the decrementation from 20 to 0 or 100 to 50, for example. And the last one will be range, and the range will execute some function on a given range. And for the range, we'll also define the step. It's very important to notice that here I will implement a function from a standard library, Erlang standard library, so you will find the for is exactly the same as it is libmisc. So yeah, I really recommend to go to these sources and see how it's implemented, so you get better overview how to implement custom control abstractions in Erlang. Okay, so let me first define first clause in this function. So what happens? I want to iterate from, for example, 0 to 20. So what happens when I reach the last iteration? So um, my index is equal to the maximum value in this iteration. What I want to do, I want to execute something like this to generate to execute only this function. And if it's not equal to maximum value, I want to do the following thing. I want to invoke the function. So the f is the function which will be invoked in every iteration of this loop. And then I want here as you can see, I'm building the lists. So here this will be only one list element, and here I want to build the list where the head will contain um, uh, the result value of execution of this function with index I, and then I want to for the tail of this list, I want to execute something like this. I want to increment. So I want to execute for the next element in my list. I want to pass the max to ensure that this is that the max sooner or later will be reached. And then I want to pass the function so that within the next this when this function is invoked, this f is also passed. So this is implementation of a range function which will of the for function which will count up. Let's try it in the shell. I will compile loops module. Okay, so far I need to also define two other functions, or maybe I will just remove them for now. It looks good. And now I can type something like for from 1 to 10, execute, and here I need to pass the fun, which takes only one argument I, and for this I just want to return this I, and it means it will build the list, something like this. I could also do something like IO format, um, and each element will be what I did wrong. IO format. Okay, but argument. Let's try with this. Okay, like this. W is okay. So here I have the results of this invocation of this for loop. So you can imagine that in this fun I could do some more complex stuff than just printing out the values or building the list out of these values. I could do full business logic inside of this. Okay, so let's define two other functions now. In this example, if I would use this function, it wouldn't be able to count down, so I will implement this countdown right now. I will call it for down, let's say, and this will be quite similar to this function, but in this case I want to go down for down, and if I reach the mean, the minimum value, I just want to call the function. And in any other case, when the value is passed, I want to do the following. I want to call the f to build the list like this, and I want to put similarly to this one, I want to put result of this invocation as the head of the list, and then I'm passing here for down I minus 1 min and then f, and this way using higher order function and pattern matching, I build loop which is able to execute with decrementation. So let's test it now. Again, I will compile a loops module. It's fine, and then I can just execute for down. I can do something like 10 to 1, and then I'm passing fun, of I, and okay, and now this loop executes the countdown, and for each countdown it will execute this function. So far so good. There's probably a way also to connect these two approaches. Um, I'm I'm just doing it for the demonstration sake. So the last thing would be the range function, and the worth now. Before I will implement this, this function will contain one, let's say, inconvenience for the client of this API, and maybe once I will implement it, I will explain what I mean. So this one executes the logic on some range, and I will pass some values, the range here, for example, from 0 to 10, and then I will also pass the step, and the step is the function which tells which will be executed. It's a fun which will be executed on this argument to increment it. So the inconvenience I mentioned is that since the current implementation for this, let's say I'm trying to simplify it as much as possible. Basically, the client of this API needs to make sure that this range, this maximum value will be reached by this step. So if you will start with 1 and you want to go to 10 and your step is I plus 2, then you will never reach this step because it matches exact value of the maximum value. It will just create the infinite loop. To fix this, I will in next videos I will introduce the concept of guards, which is a very good way to implement this kind of situations. And but for now, let's assume that user always needs to know that it needs to really make sure that this range can be reached, this maximum value can be reached with this step, assuming that it starts with this minimum value. Okay, so here I will execute something like this. So, oops, sorry. Again, you can see that for the max, when I reach the max, I just want to call the function. I don't want to try to process the tail of the list further. There is no tail. This is the maximum. This is the end. Okay, maybe let me also put here the export range with 4 arguments. And in case I haven't reached the maximum, I can do something like this. And then, yeah, here we could have 0, here we could have maximum 10, and here we could have the step I plus 2, and it would count like 0, 2, 4, 6, 8, and 10, and then it will end the iteration because it will jump to this clause of this function. Therefore, yeah, this is the way to implement range with the step, with the custom step. Okay, range step I. Of course, yeah, here I'm building the tail of this list. So here, instead of passing, like here I'm passing just the calculation, I minus 1. Here I'm invoking this function so that within this function the calculation will be executed. So the client needs to provide this calculation. He wants to tell this function how the incrementation should happen, +2, +3, or whatever. Here the maximum value. Here the step again we need to pass, and the function which needs to be executed. So here we are operating on 2 functions. One, the step function, which tells how to increment this index, as well as this f function, which will be executed to build each element of this list. Okay, so when I'm here, I can just do something like this. My function is built. I can compile it. Okay, I got the warning that the step is not used, but this is fine for this demo. So I will use now. So first of all, I need to define the step. It will be fun, and to define this fun, I need to write something like I, and I want to tell I plus 2, for example, or I plus 1 will be the standard case, and I also will define the f function, which will be whenever the index comes, I want to just yeah, return it. Okay, and now I can execute my range. So from start to end, I want to execute for my range 1 to 10, and with the step function step, which will increment by 1, I want to execute function f. And as you can see, it built for me this list from 1 to 10. Now let's say I want to define new step by 2, so it will increment by 2. And okay, and now I can pass here step by 2, but here I need to ensure that the range will be correct, because if it would be 1, it would count like 1, 3, 5, 7, 9, 11, and then it would go to infinity. And yeah, it would be infinite loop because it wouldn't reach this 10, so it couldn't compare the max. And this is what I mentioned earlier. In the future video, I will show you how to fix it with guards. Okay, so 0, and it will increase by 2. Okay, so I had 0, 2, 4, 6, 8, 10. So this is the way to implement simple range function. Also, to show you that this 4 was already implemented in this libmisc, I can just type libmisc 4 110, and then the fun I and let me see what's wrong here. Okay, for some reason I don't get this function. Okay, maybe it's not included here. So okay, it was worth implementing our custom function. So now what's the advantage of this? The biggest advantage is that when you can implement your custom uh, control abstractions, the code decreases in size, and the code gets much clearer, much readable, because you don't operate with set of limited statements like for or for each, where you usually pack a lot of stuff within this to let's say customize the loop for your custom needs. You can implement your own control abstraction and tailor it to your custom needs, and then the code really is really much more concise and robust and readable. So of course the smaller code is better code because it's just more readable, easier to maintain, and easier to spot bugs. So that's it for this lesson. Thanks for listening. In the next lesson, I will be talking about list comprehension, also very important concept for in Erlang and in functional programming. So stay tuned and talk to you next time. Cheers.